Hello, welcome to Nalit Aizol video tutorial on computer graphics. This time we will be talking about output primitives. The contents are taken from a book called Computer Graphics C Version, written by Donald Hearn and Pauline Baker. Now in this particular unit we will be talking about introduction, point drawing, line drawing, circle generation algorithm, ellipse generation algorithm, other curves, field area primitives, and so on. So let us first try to understand what are raster and vector. As we have already discussed before in the previous unit, raster is completely specified by a set of intensities for the pixels positioned in the display. Shapes and colors are described with pixel arrays. Scene displayed by loading pixels arrays into the frame buffer. And vector is a set of complex objects positioned at specified coordinates location within the scene. Shapes and colors are described with sets of basic geometric structures. Scene is displayed by scan converting the geometric structure specifications into pixel patterns. So let us give an example of raster. In raster, as it is based on pixel, suppose we have a pixel array like this. This is a pixel array. If we want to draw a line, we will draw a particular pixel here, particular pixel here, another pixel here, and so on. So it will not be smooth, and it will be having a staircase like structures. Okay, when it comes to vector, we will have a smooth surfaces like this. Now let us see the output primitives of computer graphics. Basic geometric structures used to describe scenes can be grouped into more complex structures. Each one is specified with input coordinate data and other information about the way that object is to be displayed. Examples are point, line, circle, with each having specific coordinates. Construct the vector picture. Okay, these are the output primitives. So in the output primitives, what we need is that we need to draw a point, a particular point. We need to draw a line, a curve, a circle, ellipse, and so on. Okay, so in this unit we will try to understand how these points, lines, curve, circle, or ellipse are drawn. In digital representation, display screen is divided into scan lines and columns. Pixel positions are referenced according to scan line number and column number. Scan line starts from 0 at the screen bottom and columns starts from 0 at the screen left side. Screen locations or pixels are referenced with integer values. The frame buffer stores the intensity temporarily. Video controller reads from the frame buffer and plots the screen pixel. So what we have is that in pixel position, suppose this is your X line, this is your horizontal, this is your Y line, this is your vertical line, and everything will start from here, 0, 0, and it will start from here. This is your bottom left corner. This is your 1, 2, 3, 4, 5. 0, 1, 2, 3, 4, and 5, and so on. It will go on like this. On the vertical level also, 1, 2, 3, 4, and 5. Okay, so this is how pixel position will be calculated. And the intensity frame, we have talked about the frame buffer before. So the frame buffer will store the intensity of the light reflected on the screen temporarily. And then we have video controller that reads the frame buffer and plots the screen pixels. Okay, whatever the intensity value stored in the frame buffer will be plotted out on the screen. Now let us talk about point drawing. This is your point. As you can see, this particular line is the x. This is the position of the x-axis. This is the position on the y-axis. Suppose we say this is 1, 2, 3, 4, 5, and 6. This will be 6 on the x-axis, and 1, 2, 3, 4, 5, and it will be 5 on the y-axis. Okay, point drawing, converting a single coordinate position furnished by an application program into appropriate preparation for the output device in use. In raster system, black white setting the bit value corresponding to a specified screen position within the frame buffer to 1. So in a black and white system, 0 and 1 is simply enough to indicate whether it is black or white. Okay, and suppose in RGB, loading the frame buffer with the colors codes from the intensity that are to be displayed at the screen pixel position. So in RGB, since we have red, green and blue, these values will be stored in a three-dimensional matrix. Okay, so it will be stored in three-dimensional matrix because we need to have the value of red, green and blue. Now let us see the line drawing algorithm. As we can see before, this is your x-axis, the bottom line is your x-axis, and the vertical line is your y-axis. We have one point here on the x-axis, this is your x1. We have another point on the x-axis, this will be called as x2. This particular point on the y-axis, we call it y1, and this particular point on the y-axis, we call it y2. So if we have this particular x1, y1, x2, y2, we can draw a line like this. Okay, so we'll try to find out how these lines are drawn. Line drawing. A straight line is specified by two endpoint positions. Line drawing is done by number 1, calculating intermediate positions between the endpoints, directing the output device to fill in the calculated position as in the case of plotting single points. This is your first endpoint and this is your another endpoint. We need to know the source and the destination. Okay, so if we have these two endpoints, this is one endpoint, endpoints 1, this is endpoints 2, we can draw a line. That is how the algorithm works. Plotted positions may be only approximations to the actual line position between endpoints. A computed position 10.48 is converted to pixel. So in particular pixel, we do not have a decimal points. This is decimal points is a problem. Okay, so this decimal points is a problem because in pixel there is no decimal points. What we have is, if we have 10.49, we will round it down to 10, and if it is 20.51, because it is above 0.5, so we round it as 21. All right, so since we are rounding it up and down in pixel position, it will cause a stair step appearance. All right, it will cause a stair step appearance, as we have understand before. So suppose this is your pixel, and suppose we want to draw a line. It is very difficult to draw a line with this pixel unless we have a very high resolution. All right, suppose we want to draw a line here. What we can have is, we can have green one here, okay, this is how it will work. Now what we see here is that we have a stair step like structure here. Now this is the most important formula. The Cartesian interception equation for a straight line is y equals to mx plus b. This you have to remember, and where m is the slope and b is y-intercept. M is the slope and b is the y-intercept. Okay, so m represents the slope of a line and b represents the points where it crosses the y-axis. Okay, here we have, this is your x line, this is your y line, and suppose we have a line like this. This is a particular point where it crosses the y-axis. This is called your b. This is your y-intercept. Okay, and then this particular slope, this slope is your m, and then the formula of this particular line is y equals to mx plus b. Okay, you have to remember this. And then for line segments starting in x1 y1 and ending in x2 y2, the slope is m equals to y1 minus y2 divided by x1 minus x2, and b, the y-intercept b, is equals to y1 minus slope into x1. You have to remember this formula and this formula for the rest of your life. You should never forget this. For any given x interval delta x, we can compute the corresponding y interval delta y as delta y equals to m into delta x. Delta simply means changes of x, changes the position of x. Suppose first you calculate the, first you have your x here, this is your first x, and when you change it to when you try to plot another x, this is your x2. That means there is a change in the position of the x. Okay, likewise you will have y1 here, y2 here, and so on. So when you move from x1 to x superscript 1 to x superscript 2, then there will be change of movements. All right, so simply this delta means there will be a change in the movement of the on the x-axis, and then there will be change on the movement on the y-axis. Okay, so this delta. Now on raster systems, lines are plotted with pixels, and step sizes in the horizontal and vertical directions are constrained by pixel separations. Scan conversion process samples a line at discrete position and determine the nearest pixel to the line at its sampled position. In this digital world nowadays, we use raster because most of the output devices are using a pixel based display. This is a pixel. Most of the output devices are pixel based. Here, as we sample along the x-axis, suppose we have, this is the first endpoint, this is your x1 y1, and this is your x2 y2. As we move from these particular endpoints to this particular endpoints, we can either move it towards the x-axis, this is sampling along the x-axis, or we can move sample along the y-axis also. It doesn't matter. All right, now whatever we have studied now, let us try to put it into good use. Okay, this is your graph on the x-axis, this is your graph on the y-axis. Okay, and here let us try to give a pixel value. Suppose this is 1 2 3 4 5 6 7, and on the y-axis also we have 1 2 3 4 5 6 7. For understanding, we will choose a very simple example. Suppose the first endpoints here we pick is this particular pixel. This particular pixel is your first endpoints, and suppose we have another endpoints. Let us pick this particular pixel. Okay, this is our particular pixel. Now we have chosen two pixels. What are the coordinates of these two pixels? x1 is 1, y1 is 2. Here your x coordinates is 5, y coordinate is 6. This is your particular pixel. So given this particular two endpoints, x1 is equals to 1 and x2 is equals to, on the x-axis, as you can see, x2 is equals to 5, y1 is equals to 2, and y2 is equals to 6. Okay, this is the value that we have. Okay, now let us try to understand this a little bit more using this formula. Now let us try to find the value of the slope. M is equals to y1, as we can see from here, m is equals to y1 minus y2, x1 minus x2. So substituting the value of all these values, we have y1 is equals to y2 is equals to 6 divided by x1 is equals to 1, x2 is equals to 5. Okay, so if we calculate this, we have minus 4 divided by minus 4, minus and minus cancel out, and the value of m is equals to 1. Now let us also calculate the value of b. B is equals to y1 minus m into x1. We have 2 minus m is 1 into the value of x1 is also 1. Here we have 2 minus 1, which is equals to 1. I am choosing a value so that it becomes easy to understand. Okay, so what the value that we already have here is m is equals to 1 and b is equals to 1. Okay, these are the values here we have now by calculating this. Okay, now let us try to find out the value of y when x increases. All right, so let's see. When the position of x is at 1, we have the position of y at 2. Now let's see when the position of x is at 2. Okay, let us see y value of, let us just put a subscript here. That means it is going to change. All right, so y2 is equals to, as we can see, we have mx plus b, mx plus b. In this particular case, x will also be moving. All right, so we already know that m is 1. The next value that x will change is 2. We already know that this is the next position for x. Okay, so if we put 2 here, we already know that the value of b is 1. Sorry, b is 1, which will be equals to 2 plus 1, and it means it will be 3. Okay, the next position of y will be 3. When this part of x is true, when this x is true, y will be 3. Okay, so let us try to find out the points when the next y value, let us say y3, y superscript 3. It means m is already 1, we know, and the next position of x will be 3. This is the next position of x. X 1 into 3 plus b is 1. So easily we can know that 3 plus 1 is 4. So the next value of y will be 4. Likewise, a value le hi en le taila x kha lo change le don next pixel la change do na chumi wang chuan m hi 1 ani a, x value chu 4 lo ni tonga ani chuan b hi 1 ani a ani chuan kan value thar nei tur chu 5 lo ni ta a. So next y value chu 5 lo ni ta ni. Okay, this is how a line is created in pixel. Hey, hi line pixel la in create dan lo ni ta anal lo viewa amar chu pixel hi alen em wanga lo ni ta ni to na hian pixel hi lian lo selang chuan line ang thowin kan hudon ti na ni a ba se hey pixel kan ti hi lian pui pui example la tan chu kan hmana wangin alen em wangin ti hian alak nal lo ta ni apoi mo bera chun endpoints kan nei anga ya kan endpoints ni atang khan hemi formula hi kan hriat chin anga ni slope formula kan hriat chin anga ya y intercept formula kan hriat chin anga ya pai hemi hi equation of line shim ani he equation of line hemi da pathum mi kan hriat chin em mangai ni line kan draw don chuan. Okay, chuan assignment a in lo ti tur chu endpoints pakhat na x1 y1 hi 2 7 ni ta se x2 y2 hi 11 13 he hi lo ni ta se ending e line in draw ang tika in assignment turani assignment question number 1 ei hi tuna kan chaw ang hian in lo chok chuak vekang hemi line ami tur hi in lo chok chuak vekanga in hriat tur chu tuna hian chuan hemi m le slope le b hi 1 ve ve chuak to don lowa decimal points aron chuak to mai thei ni decimal points aron chuak chuan in hriat tur chu in round upang entunan example aron chuak kha 2.7 ani chuan 3 in round upanga 2.4 ani chuan 2 in down ang okay ole khati zong kha ani thank you